To find the resultant of any concurrent forces, you can use one of three methods: the parallelogram method, the triangular method, or the rectangular component method. The first method is the parallelogram method. The resultant of two concurrent forces can be obtained graphically by constructing a parallelogram. In this illustration, the forces P and Q are drawn to scale. The forces acting at O form two sides of the parallelogram. The diagonal that passes through the origin, O, is the resultant R. The parallelogram law states that two forces whose lines of action intersect can be replaced by a single force, which is the diagonal of a parallelogram that has sides equal to the two forces. The parallelogram law is based on experimental evidence only. It cannot be proved or derived by mathematics. The second method is the triangular method. The construct shown at left suggests that forces may also be added by arranging vectors tip to tail. The method shown at right consists of moving either force parallel to itself until the tail coincides with the tip of the fixed force. The closing side of the triangle forms the resultant with the tail of the resultant at the tail of the fixed force and the tip of the resultant at the tip of the moved force. As can be seen from the construction, the order in which the forces are combined does not change the resultant. Let's look at example 1. Two forces, S and T, act as shown in figure A at point O. Obtain their resultant graphically by the parallelogram method and the triangular method. For the graphical parallelogram method, a parallelogram with sides equal to S and T is drawn to scale in figure B. The diagonal forms the resultant. The magnitude and direction of the resultant are measured and found to be R, or resultant value equals 590 pounds with an angle of 20 degrees. When you want to obtain the same results using the triangular method, draw a fixed force S at point O as shown in figure C. Move force T parallel to itself until its tail coincides with the tip of force S. The resultant forms the closed side of the triangle. The tail of the resultant is at the tail of the fixed force, and the tip of the resultant is at the tip of the moved force. Measurement of the magnitude and direction of the resultant gives an R value, or resultant value, equal to 590 pounds with an angle of 20 degrees. In example 2, a ship is pulled by two tugboats, as shown in figure A. The resultant force is 3 kip parallel to the x-axis. Find the forces exerted by each tugboat graphically using the triangular method. The resultant of 3 kip is drawn to scale parallel to the x-axis from O to V, as shown in figure B. The line OT is drawn through O at an angle of 25 degrees, and the line VS through V at an angle of 35 degrees. The two lines intersect at point U. Force P is directed from O to U, and force Q is directed from U to V. Measuring the magnitude of the forces, we obtain P equals 2.0 kip and Q equals 1.5 kip. In example 3, 2 cables are used to pull a truck as shown in figure A. The resultant force lies along the x-axis. Determine the magnitude of the force Q and of the resultant R by trigonometry. The force Q at an angle of 40 degrees is added to the force T at an angle of 30 degrees to form the resultant R at an angle of 0 degrees in a tip-to-tail fashion, as shown in figure B. From the construction, angle B equals 40 degrees and angle C equals 110 degrees. If you apply the law of sines, you will have the equation sine of 30 degrees divided by Q equals sine of 40 degrees divided by 55 equals sine of 110 degrees divided by R. Solving the equation for Q and R, we will have Q equals 55 times the sine of 30 degrees divided by the sine of 40 degrees equals 42.8 kilonewtons. Shown here, the resultant of three forces, P, Q, and S, is determined by repeated application of the triangular method. First, add P and Q to find the resultant R1, 2. Then, add R1, 2, and S to find the resultant R of the three forces. Algebraic results could have been obtained by applying the trigonometry of oblique triangles, first to triangle OPQ, then to triangle OQS. The polygon method at right can be described in the following way. You can use this method if you have three or more forces. First, leave the fixed force P at point O, then move Q parallel to itself until its tail coincides with the tip of P. Next, move S parallel to itself until its tail coincides with the tip of Q. The resultant R forms the closing side of the polygon, with the tail of the resultant at the tail of the fixed force P and the tip of the resultant at the tip of the last moved force S. The order of addition of forces does not change the resultant, as seen from the construction shown here. The main point is that the closing side after arranging the forces in a tip-to-tail fashion is the resultant of the forces. In the fourth example, the forces act at point P. Obtain their resultant graphically by the polygon method. First, the four forces are drawn to scale in a tip-to-tail fashion in Figure B. The resultant acts from the tail of the first force to the tip of the last force. The magnitude and direction angle are measured, and the resultant is found to be 4.9 kilonewtons with an angle of 24 degrees.